Welcome to the video on Converse, Conditional, and Biconditional. You should be on page 7 in your notes packet. And just a reminder that if I say something that doesn't make sense, you can always rewind and then replay the video, or just make a note to yourself in the margin to ask me a question about it when you come back to class the next time. So first things first, a statement. We need to talk a little bit about what a statement is before you can understand a conditional. A statement is a sentence that is either true or it's false. So the statement, today is Monday. That's a false statement. But true or false? A conditional, you've heard probably a dozen times already. In fact, you're going to be very familiar with these, but we'll go through what exactly it is. It's a compound statement that joins two statements together by using the words if and then connecting them using the word then. So for instance, one that I love to use with my kids at home, if you clean your room, then your friends can come over. And I'm sure that as teenagers, you hear these conditional statements at least 100 times a day. But again, it begins with the word if, connects the two little statements together by using the word then. I like to think about a conditional statement as a promise. I'm promising my kids that if they do the first part of that, if they clean their room, then as a result of cleaning their room, their friends are able to come over. Now notice, the conditional is going to be a false statement only when I'm a liar, only when I break my promise. If they clean their room, if they do this yellow part, but I fail to let their friends come over, then I've broken my promise, and that conditional is a false conditional. So down at the bottom it says, find the truth value of each of the following conditional statements. When it's asking me to find the truth value, what it's really asking me to do is tell whether the statement is true or whether the statement is false. In other words, did I keep my promise or did I break my promise? So number 1 says, if a number is even, then it must be true that that number is prime. Well, let's take a minute and think about some even numbers. 2, 4, 6 are the first 3 that come to mind. Those are all even numbers. Does that number then have to be prime? Well, the only one that's prime in that list is 2. The other 2 are not. So just because a number is even doesn't guarantee or doesn't promise us that it has to be a prime number. And for that reason, the truth value of that conditional is false. Number 2 says if a number is a multiple of 3, then it must be an odd number. So again, I'm going to start off by considering some familiar multiples of 3, numbers like 3, 6, and 9. If I have a multiple of 3, does that mean that that number also has to be odd? Well, in 2 of the cases it is, but in this case it is not. And that conditional also is a false conditional. All right, the next one says, if a square is a quadrilateral, then a circle has to have 3 sides. This one is a little crazy because it's not quite as straightforward as the other 2 are. It says, if a square is a quadrilateral, well, quadrilateral, remember, is a polygon with 4 sides. And since all squares are quadrilaterals, the first part of that has to be true. But does that guarantee that a circle has 3 sides? Well, a circle doesn't have any sides. And so therefore that promise too is also broken, making that conditional a false conditional. The last 3 examples I'm not really thrilled about, and as your teacher I have the prerogative of omitting those, so I'm going to go ahead and skip over 4, 5, and 6, and we're going to talk about some hidden conditionals. The conditionals that we looked at so far were pretty straightforward, but they're not always. Sometimes the word if and then don't necessarily appear in a sentence, but we can still understand that its general meaning is that of a conditional. So for instance, they give you the sentence, vote for me and I'll fix unemployment. What they're really saying there is that if you vote for me, then as a result of that, I'll fix unemployment. So those are hidden conditionals. They want us to, in these next examples, go ahead and write each of them in if-then form. So they want our sentence to start with the word if and connect using the word then. So number 1 says, if I go to work, or sorry, I will get paid if I go to work. Well, what they're really saying is, if I go to work, that's the condition that has to be met. So if I go to work, then as a result of going to work, I get paid. Now this first part of it, the condition that has to be met, is called the hypothesis. So I go to work is kind of the hypothesis. Think about that as the condition that needs to be met. The conclusion is what happens as a result of that condition being met. In this particular case, I get paid. So here's, again, is my hypothesis. This guy called the conclusion. Number 2 says, I take medicine when I don't feel well. Well, again, what I'm really saying here is if I don't feel well, then as a result of that, I take my medicine. So the hypothesis here is that I don't feel well, and what happens as a result of the hypothesis, the conclusion, is that I take my medicine. All right, up at the top of the next page, they want us to circle the hypothesis and underline the conclusion. So again, I'm thinking about the hypothesis as the condition that needs to be met. The conclusion is what happens as a result of that hypothesis. So number 1 says, if mean Miss Bailey assigns homework, you'd better do it. Well, the hypothesis, the condition is that Miss Bailey assigns the homework, so I'm going to circle that. The condition that needs to be met is that you do the homework. Number 2 says, you can assemble the bicycle if you follow these easy instructions. Be careful here, because what they're saying in this conditional is that if you follow the instructions, so if the condition is met, there's the hypothesis, then as a result of meeting that condition, you're able to assemble the bicycle. Number 3 says, I carry an umbrella when the forecast predicts rain and the weather looks threatening. Well, the condition that we meet here is that the forecast predicts rain and the weather looks threatening. And what happens as a result of that, the conclusion, is that I carry an umbrella. At this point, I'm going to let you go ahead and circle the hypotheses and conclusions for the last 3 remaining statements. So go ahead now, pause your video, and go circle and underline for problems 4, 5, and 6. Okay, go ahead, check your answers for 4, 5, and 6. Make sure that you circled the same things that I circled and underlined the same things that I did. And if you don't have any questions about any of those, you can go ahead and we'll talk about Converse. If you do have a question about any of those, I want you to jot it in the margin right now so that you'll remember to ask me about it the next time you come to class. All right, we need to talk a little bit about Converse. Converse is what happens when we take a conditional statement and we switch the hypothesis and the conclusion. Here's how I remember Converse. See the C and the O, the first 2 letters in that word, C-O? I tell myself this stands for change the order. So the converse is what we get if we take a conditional statement and we change the order around. Down at the bottom for these examples, they want us to do 3 things. They want us to state the truth value of the original given conditional. They want us to write the converse of that. And then part C, they want us to state the truth value of that conditional. All right, so I'm going to go ahead and take a look at these. Number 1 says, if 2 angles are vertical angles, then they have to be congruent. Well, that is absolutely positively a true conditional statement. The video you watched the first day with respect to vocabulary talked about that. And then yesterday or today in class we did some practice as well. So that's true. The converse of that is what I get if I switch the order. So I'm going to keep the if, I'm going to keep the then in the middle, but now I'm going to take and change the order of these two guys around. So I'm going to say if they are congruent, or in other words, if two angles are congruent, then they are vertical angles. And if I think about that statement for just a minute, I can have two angles that are congruent. Two right angles would be congruent. Two angles that each measured 60 degrees would be congruent. Just because they're congruent does not necessarily mean that they have to be vertical angles. So while the original conditional was true, the converse itself is false. All right, and then number 2 says if x squared is equal to 16, then it must be true that x is equal to 4. Well, that is a false statement. Gasp. Yes, it really is. I'm going to say when the value of x is equal to -4, x squared is equal to 16, but our x value is not equal to 4. To find the converse of that, again, I'm simply going to switch my conditional or my hypothesis and my conclusion. So if the value of x is equal to 4, then it must be true that x squared is equal to 16. Well, anytime x is 4, the value of x squared is equal to 16. So the converse has to be true. So the whole point of this is that a conditional and its converse may or may not have the same truth value. All right, and in the interest of not making this video too long, I'm going to skip number 3 up at the top and head right into biconditionals. Biconditional is what we get when we combine two conditional statements. So the way or the connecting words that we have for this are the words if and only if. So some statement is true if and only if that other statement is also true. Biconditionals are true only when both statements that make up the biconditional are true. So an example of this would be to say a triangle is isosceles, and I'm going to use that triangle symbol to represent triangle. So a triangle is isosceles. And the connecting words here are if and only if. It has two congruent sides. So the big idea in this problem is that the connecting words are if and only if. And what that really means is it means if a triangle is isosceles, then it has to have two congruent sides. And if a triangle has two congruent sides, that triangle is isosceles. All right, down at the bottom of the page, they want to know which of the following is a biconditional. Well, biconditional is going to connect using the words if and only if. So I'm going to go ahead and look for the multiple choice answer that deals with if and only if. So letter C says an angle is acute if and only if its degree measure is less than 90. So that's the word that connects using the word if and only if. That makes it the biconditional. I'm going to go ahead and skip those last two examples down at the bottom of the page. At this point, if you have questions, I'd appreciate it if you jot them in the margin so that you can remember to ask about it the next time that you come to class. If not, have a great night, and I will see you next time you come to class.